Hey guys, welcome to Safi Mixed. In this video, you will learn about a basic concepts of thermodynamics related to the different amounts of heat needed to heat up, that is, raise the temperature, and to evaporate the same amount of water. In other words, you will learn about the difference between the heat capacity and the heat of evaporation of water. If you place a cup of water in a kettle on a stove that produces heat at a constant rate, and note the time it takes to get boiled, and then subsequently note the time for its complete evaporation, you will notice that the duration for evaporation is quite long. I will talk about the physical reason for the difference between these two durations. From our college physics, we know about the definition of heat capacity and heat of evaporation. From these definitions, we can find the amount of heat to raise up the temperature of certain amount of a substance and the amount of heat needed to get that amount of the substance evaporated. These amounts of heats in terms of specific heat capacity, mass of the substance, and heat of evaporation are respectively given by these two equations, where I'm representing them with Q sub 1 and Q sub 2. Q sub 1 equals mc delta T. The C in this equation is in fact the specific heat of the substance, and delta T is the change in temperature that one wants to bring. And in the second equation, L sub V is the latent heat of evaporation, and M in these two equations is the mass of the substance. The first of these two equations says that if we know about the heat capacity of a substance, we can find the amount of heat Q1 for a given mass of the substance by changing the temperature to the desired value delta T. And the second one says that if we know about the latent heat of evaporation, we can find the amount of heat needed to completely evaporate a given amount M of the substance. Now, if we apply these equations to 1 kilogram of water, then the amount of heat Q1 needed to raise the temperature of 1 kilogram of water from 0 degrees Celsius to 100 degrees Celsius is given by 4.19 into 10 raised to the power 5 joule. Similarly, the amount of heat Q2 needed to evaporate completely 1 kilogram of water is given by 2.256 into 10 raised to the power 6 joule. You see, there is a huge difference between these two values of heat. So let us try to understand the reason for this difference. From kinetic theory, we know that the change in temperature of a liquid is linked to the change in the average kinetic energy of molecules. In liquid water, the molecules are relatively free to move within the water, but are not completely free to leave the surface of water. In fact, every molecule interacts with other neighboring molecules through hydrogen bonding. For a given molecule, these bonds are not stable. Rather, the hydrogen bonds form and break with molecules that come in its path. When we heat up the water, that increases the average kinetic energy of the molecules, which in fact increases the rate of breaking and forming of hydrogen bonding for a given molecule. At boiling point, the evaporating molecules have enough energy to break the hydrogen bond completely and get free above the surface of the water. And this complete breakage of the hydrogen bonds needs additional heat energy, which makes the heat of evaporation greater than the heat capacity of water. So it is the complete breakage of hydrogen bonds between the molecules that make the heat of evaporation more than the heat capacity of water. Thanks for watching.